You said when we go back home, we remove it.
You're gonna plug it in. Yep, that's right. Yep, that's it. All right, so for today, we're going to look at solving for zeros of quadratic equations. Then we're going to get into some inequalities. The first part should be pretty easy. Tends to be one of the easier lessons of the term. So some quick vocabulary down here. Standard form of a quadratic equation is ax squared plus bx plus c. Remember, a is always the number in front of the quadratic term, x squared. B is always the term in front of the linear term, x, and c is always going to be some number, a constant. And for today, when we solve, keyword here, solve, by factoring, you must have the equation set equal to 0. So that's going to be something kind of new today. We are going to use the 0 that's there and what's called the zero product property. So down below here in this little box, you can see the zero product property. So right here, it tells us if A times B equals 0, then A equals 0 or B equals 0. You cannot give me two numbers that multiply together to give me 0 unless one of them is 0. It's impossible. So the zero product property says if I take two things and I know that when they're multiplied together it equals 0, then one of them has to be 0. We're going to use that to our advantage when we have factors. So looking here, we have two factors. Here's one factor, here's another factor. Right here in the middle is multiplication. These two factors or sets of parentheses are being multiplied together and their product equals 0. What that means is one of those two factors must equal 0. So either x plus 3 equals 0 or the other set of parentheses x minus 7 equals 0. And today we're going to solve both of them. So if I gave you x plus 3 equals 0, yes?
I had a question. Like 1 over, so that we put a -3 and -3 on the 0.
Yeah, so you would just subtract 3 from both sides. Yeah. Yeah, so those x equals -3. So you know that if I have an x value of -3, this statement's going to be true because if I plug -3 into my first set of parentheses, it's going to give me 0. Then we have to figure out what makes the second set of parentheses equal to 0. Well, if x minus 7 has to equal 0, I'm going to add 7 to both sides, and x equals 7. So both of these are solutions because both of them make this original equation over here on the left-hand side true. So either one of these x values, if I plug them in, is going to make the original equation equal to 0. Because the first answer gets the first set of parentheses to be 0. The second answer gets the second set of parentheses to equal 0. So today we're going to be factoring and then setting our factors equal to 0. So quick vocab in your own words. What does it mean to solve a quadratic? That means we're finding where your parabola crosses the x-axis. So we're going to find the x-intercepts which is where your parabola crosses the x-axis. And in just a second, we're going to look at what that actually means in terms of your graphs. Mm-hmm. which is the right one, not 4. Here, and we'll do 2, 2, right, 2, 1. Let's pause it. And last one, we'll write 3 down. All right. So what we've been looking at graphing, we have been graphing parabolas that look like this, right? So here's an example of a parabola we graphed yesterday, today. How many times does this parabola cross your x-axis? Remember, this is your x-axis. How many times does it cross it? Twice. So this crosses 2 times. This is the most common answer. Keep in mind, I could draw another parabola like this. Also crosses 2 times. Just been flipped upside down. So that is the most common answer. You're going to get 2 solutions because your parabola is going to cross the x-axis twice. Another scenario that might happen is your parabola is just going to touch the x-axis at the vertex. Again, we could flip it upside down. So both of these examples just touch the x-axis 1 time. So another answer would be 1 time. So you can get 2 solutions, top example, 1 solution. Both of these examples have 1 solution. And then the least common one is to have no solutions. So to have no solutions, I'm gonna have to draw it over here. If I have a parabola that looks like this, will this parabola ever cross your x-axis? Never. It's just continuing up. It's never going to go down. So this has 0 solutions. And same way, if I would draw this one here, if I flipped it upside down and moved it down, this one would never cross your x-axis. So 3 situations could happen. 2 solutions, it crosses twice. 1 solution, just the vertex touches the x-axis, or no solutions where it never, ever, ever crosses the x-axis. Again, 2 solutions is definitely the most common here. See how these 2 points are the same one? Other than that, it's good. All right, so let's do our first problem. We're asked to solve by factoring. Keyword solve. Anytime you're asked to solve, you're going to get x by itself, figure out what x equals. Keep in mind, we can have 2 solutions, 1 solution, or no solutions. In order to solve a quadratic, so I've given you an equation in standard form set equal to 0. First thing you want to look for is their greatest common factor. Do all 3 of these terms on the left-hand side have anything in common? No, I saw some head shake, no. So then to factor that, you're just going to use your asterisk. So jump here. A is 2, B is negative 11, and C is 15. So take a minute, fill out your asterisk.
I had a question.
Mm-hmm.
They got 1, you want to take 0, right?
If you want to jump into us, you can. Don't worry about that. I'd rather you learn this.
It's H and C.
Yes.
Okay, I see that. Gotcha. That wasn't up there a second ago.
It wasn't.
No, I did. Okay.
So in your asterisk, you should have A in the top right and top left sections, 10 and 2. B is going to the bottom middle, so negative 11 in the bottom middle. And be careful, for the top middle, you have to multiply A times C. 2 times 15 gives us a value of 30 for the top middle section. So now we're looking to find two numbers that multiply to give me 30 and add to give me negative 11. Perfect. Negative 5 times negative 6. Order doesn't matter if you wrote the negative 6 on the left-hand side. That's perfectly fine.
1/3 for the 2 and 6.
Yep. So Keith's going ahead and reducing. We're going to reduce the 2 and the negative 6. They're both divisible by 2, which is going to give me 1 over negative 3. And now I have these two fractions that I need to make into factors. So,
Put your X back in.
yep, you're going to put your X back in only on the top. Remember, you're splitting that X squared, so you're going to get X on top of both of them, not X squareds on top of both of them. So in my first set of parentheses, I'm going to write 2x minus 5. And then the other factor, I'm just going to have x minus 3. Still equals 0. So this equals 0 just gets brought over from there. So we've just changed the way that the original problem was written. We haven't changed what it equals. We've just changed the way that it's written. I could, if I wanted to, take these two factors over here on the right-hand side, box them back together to prove to myself that they equal the original.
So this one we do the 2x minus 5 equals 0 and x minus
Look at you
3.
jumping ahead. Yes. So now these two factors are being multiplied together. There's nothing written between them. Multiplication is assumed because there's no symbol in there. So since these two factors are being multiplied together, we're going to use the zero product property to say, hey, since these two sets of parentheses are being multiplied together and it equals 0, then one of the two parentheses must equal 0. So we're going to set them both equal to 0. So 2x minus 5 equals 0, or x minus 3 equals 0. So this one just gets brought down here, and this one gets brought down here. We're just setting them both equal to 0.
It's gonna be a decimal, right?
Or fraction, yeah. Either way. So now I just want to solve both of these equations for x. So for the first one, I have 2x minus 5 equals 0. If I'm trying to get x by itself, I'm going to add 5 to both sides. So 2x equals 5. 2 is being multiplied by x, so I'm going to divide by 2. So I would have x equals 5 over 2, or 2.5 if you want to convert it to a decimal. You do not by any means have to write both answers. I'm just writing both answers so you know both of those answers are acceptable. So just one of them is good enough. You don't have to have them both. And then don't forget, we need to take that second set of parentheses, set it equal to 0, and solve for x. So this one's a little bit easier. It's just x minus 3 equals 0. Add 3 to both sides. It's just going to give you x equals 3. So we have two answers in this case, which means that if I ask you to graph this original equation, you would have to find the vertex, blah, blah, blah. We found that your graph's going to cross the x-axis at these 2 points. Would I want to graph and tell you, hey, where's the graph across the x-axis when it's 2.5? No, it'd be pretty ugly. So this is used in replacement of graphing everything, so we can figure out where it's crossing the x-axis just by using some factoring and setting things equal to 0. It's a lot easier than graphing everything. Questions on that one before I flip to the next page?
We gotta write some of them.
2, 1, 0. On the next page, again, we're asked to solve each equation by factoring, but what do you first notice is a little bit different? Say that again. So C is on the wrong side. C's sitting on the right-hand side here. We want 0 there. We want to move that 18 to the other side. So we're going to exactly minus 18. when you subtract 18, it's very important that you write the left-hand side in standard form. So do I want the negative 18 to be written first? Do I want negative 18 plus x squared? No, it's not standard form. We want to write it so that it's in standard form, meaning that negative 18 or minus 18 should be last. So I'm going to keep x squared plus 7x, then the minus 18, because the minus 18 is c. It's constant. It's just a number. And now we have equals 0 because 18 minus 18 cancels. Once you have your equation set equal to 0, you're going to check. Do we have a greatest common factor? No, no greatest common factor. So we're going to use our asterisk. So take a minute, fill out your asterisk, and find your two factors. So here we want to get x by itself. So I gotta get rid of this. How do I get rid of that? Yep. You're overthinking it. You know what you're doing. So remember, you can take your 18 and just start dividing it by numbers. So if I divide it by 2, then I take 9 and 2, 9 and 2 and put them together. So you're gonna subtract them to get the 7 at the bottom. All right, so when you fill out your asterisk, you're going to have 1 in the top left, top right, because A is 1. B is going to go to the bottom middle, so bottom middle is going to be 7. And then in the top middle, we're going to take A times C, which is 1 times negative 18, which holds a value of negative 18. So I'm on a mission now to find two numbers that multiply to give us negative 18 and add to give us positive 7. 9 and negative 2 and 9, or order does not matter as long as you have them both. That'll give you a negative 7 in the bottom. You want a positive 7. So just switch your signs. Ask yourself, can you reduce either one of these fractions here on the left and the right hand side? No, so we're going to put our x's at the top and then we're going to convert them to two factors, x minus 2, x plus 9, still equals 0. Now that we have our two factors multiplying together to equal 0, we're going to use that zero product property, say, hey, these two sets of parentheses are being multiplied together. I know that one of them must equal 0. So either x minus 2 equals 0 or x plus 9 equals 0. And then we're just taking these two equations and getting x by itself. So for the first one, we have x minus 2. To get rid of the minus 2, we're going to add 2. So x equals 2. There's one answer. For the next one, we have x plus 9 equals 0. To get rid of that plus 9, we're going to subtract 9 from both sides. That gives me x equals -9 as my second answer. Questions on this one? Jump down to letter B. For letter B, first thing I hope stands out to you is that we have equals 6 instead of equals 0. So we want to get rid of that 6 by subtracting 6 from both sides. That gives us 2x squared minus 4x minus 6 equals 0. Is there a greatest common factor? 2. We're going to factor out a 2, which means we're going to divide every single term on the left-hand side by 2. So 2, 4, and 6 are all divisible by 2, so we're going to factor it out. So really, we're just dividing by 2, dividing by 2, dividing by 2. So that's going to give us 1x squared plus 2x minus 6. Yes, minus 3. Thank you. Oh. I would have been really confused when I tried to factor it. Thank you. All right, so we took out that greatest common factor. Now we're going to take just this part right here and factor it further using our asterisk. So we're not going to do anything with that 2 out front. The greatest common factor, we're just going to leave it there. We're going to fill out our asterisk with just this highlighted portion in the middle. So 1 in the top left, top right, 2 in the bottom middle, and 1 times -3, which is -3 in the top middle. So now I'm looking for two numbers that multiply to give me -3 and add to give me +2. Yep, -1 and +3. So the only numbers that multiply to give me 3 are 1 and 3. I just have to figure out which one needs to be negative. In this case, the 1. So now my x's are going to go up to the top because nothing in either one of these is going to reduce. So I'm going to have to go over here. When I move over here, I have to bring the 2 over the greatest common factor. And now instead of that highlighted portion, I've broken that apart into 2 sets of parentheses, x minus 1 and x plus 3, still equals 0. So I've taken that highlighted portion and I've changed it into this factor times this factor. Still equivalent to the original. We've just breaking it up into smaller parts, smaller pieces. Are you okay so far? Am I going too fast? You good? Go. Hold on.
You're going to open the next problem. You're going to get this. You have to reduce both sides. So if you were to write the set that I have up there, you would just have the 2 sets of parentheses, which means you modify the problem. Which is why we like that 2 has to be out front because ours actually equals this right here, where yours would be the simplified version. So for this one, it doesn't matter, but no, for this one.
Would you agree that now I have 3 terms being multiplied together? The 2 is being multiplied by the first set of parentheses x minus 1, which is being multiplied by the second set of parentheses x plus 3. So I have 3 terms, 1, 2, 3 terms. I'm gonna set them all equal to 0. If I set the first term equal to 0, will 2x ever equal 0? Will 2 ever equal 0? I said x. No, 2 will never equal 0. Mark it out. So put a little slash mark through your equal sign. It doesn't work. Sometimes you'll take out a greatest common factor of like 2x, where you would have to solve for x. In this case, you don't. So for the second one, x minus 1 equals 0. Go ahead, add 1 to both sides. You get x equals 1 as an answer. Can we what? For the second set of parentheses, we're going to take the x plus 3 and set it equal to 0. Subtract 3 from both sides to get an answer of x equals -3. Questions or concerns on this one? I am pausing to leave it up there for a second. Very good. Anything you want explained again while we're pausing?
So the reason why you took that two out of like take it out because you took it out earlier. Is that
So
why?
like right here?
Yeah, like if I wrote 2 times, like how I would put it out for the formula, like when we do the quadratic equation, like I wrote out 2 parentheses 2 or x minus 2x minus 1 and then 2x plus. That's how I wrote it out, and then that's how I worked it out. Until I looked up it and seeing that that's not how I did it. Like can you see where I wrote? I have 2, but I didn't take this out. I just wrote 2x minus 1 and then 2x minus 3 and then set those equal to 2. And that's 0.5. Burn. Sorry. So you have to use this in here. No. Okay, so there's one. Okay, so that's where I got it. Okay, that's why I was wondering. You use that to A. Yeah. Okay, that's what I was thinking. Gotcha.
Sure. All right, now we're going to solve quadratic inequalities. So remember, inequalities don't have equal signs. They have greater than, less than, greater than or equal to, or less than or equal to symbols. We're going to solve them initially very similar to what we just worked on. So we're going to, first of all, make sure we have 0 on one side, which we do right here. We're going to take just this information and we're going to factor it using our asterisk. We're going to ignore the symbol until the very end kind of this problem. So we're going to factor the quadratic that we're given x squared minus 2x minus 3. If I do that, A is 1, B is -2, and C is 1 times -3, which is -3. So now I'm looking for 2 numbers that multiply to give me -3 and add to give me -2. 1 and -2. I mean 1 and -3. They're good. Yes, up here. So looking at your 2 fractions here and here, we cannot reduce. So we're going to have x plus 1 and x minus 3. We're going to continue and set them both equal to 0. So x plus 1 equals 0, x minus 3 equals 0. Subtract 1 from both sides. That gives us x equals -1. Don't circle it because it's not your final answer. We're gonna have to do a little bit more work to get our final answers for these. Yep. we're gonna deal with the inequality sign after we find these two numbers. So the equal signs are fine right now. So x equals 3. So here we found two x values. But keep in mind, the original wasn't equal signs. We're trying to find intervals where this equation is true. So we're trying to, we can make you do these with graphing. You're going to find what regions will satisfy this inequality. So join me on a little tangent. I know. If I can figure out how to change it. Here we go. So if I were to graph this parabola, we're trying to figure out whether this whole region here will satisfy the inequality, or if this region here in the middle will satisfy them. So we have to figure out which region is going to make this inequality up here in the original true. To do that, we only care about these two numbers right here, because those are the two solutions. So what's that, -1? So pretend this is -1 and this is +3. We need to check a value from each region to see whether or not the original equation inequality, is true or false. So if you had to pick a number in each region, so you can't pick -1 because it's like the borderline. Pick a number that's smaller than -1. What number is smaller than -1? -2. So if Kenny says -2, we're going to check it. It's going to be in this region right here. I'm going to plug -2 all the way back into the original. So 0 is less than or equal to -2 in parentheses squared minus 2 parentheses -2 minus 3. That's a calculator thing, right? All that right there. So take a minute, type all this in your calculator. What'd you get? What'd you get? Ooh. Everybody has different. Make sure, first of all, that you're typing it in exactly like I have it written. The negative goes inside with the 2 before the squared. And then this one should have, let's see. You forgot your squared. So let's insert that. And then you're just going to type this piece right there, that part. And then we're going to check to see if that number. Oh, you got it. You want to calculate it? All right, so do we agree that the answer is 5? All right. Ask yourself, is this a true or a false statement? Is 0 less than or equal to 5? Yes. That tells us that this yellow section that I have highlighted is going to be our solution. The tricky part is, how do we write that final answer? So we could continue on and try to plug in a number between -1 and 3. I would use 0. If you use 0, you're going to have 0 is less than or equal to -3, which is false. So that blue region is not going to be part of your answer. And then if we plug in another value over here to the right of 3, we get another true statement. When this happens, we have two sections on our x-axis that we care about. We care about this section over here on the left and this section over here on the right. So these values and these values. Ivy Tech mandates on your final exam in one question like this, you have to write your answer in interval notation. Would you agree with me that this highlighted region could continue to the left forever and ever and ever and ever? It just keeps expanding. I just don't have room to keep going. So it's going to go towards negative infinity. It's going to the left where your numbers are getting smaller and smaller and smaller. and smaller and smaller forever and ever and ever. Where does this yellow section stop? At -1. For this one, we have to ask ourselves, can it touch -1? That relies on this right here. So if it has the equal to sign in it, we're going to use a bracket. So this right here represents the left-hand side of that highlighted region. Hi, Nathan. You need a packet? Perfect, sorry.
Sure. It's harder to sign than I can think.
We have another region that we need to investigate, right? So this region over here is also going to work because it just goes underneath the parabola and around. We're going to unite, so we're going to put a little U. We're going to unite this region on the left with the region on the right. We're going to repeat kind of a similar process for the right-hand side. Where does this right-hand side start? It's yellow region. 3. Is 3 included? Yes, because the original had the equal to underneath. Is this yellow region going to head to the right forever and ever and ever and ever and ever?
So is it part parentheses, part bracket?
Yes, so it's part parentheses, part bracket. So the -1 and the -3 get brackets because the yellow part will touch them. You can't ever touch positive and negative infinity because you can always go smaller, you can always go bigger. So positive and negative infinity will always have a parenthesis, never a bracket.
The bracket where it starts.
Yes, starts or stops, only if it can equal. If we would take that equal to symbol out of the original, these would both be parentheses.
So what we're starting with is
Then you would change this, like this started as 0, you would change it to a 0. It would still have the bracket because of this equal to symbol in the original. So the brackets are parentheses for your answers based off that symbol right there. So since that has the equal to, that's what you use the 2 brackets. If it wouldn't have that little line underneath it, you would have 2 parentheses here. And then this is our final answer. So the highlighted region goes to -infinity all the way up to -1, and then it stops. Because there's this break right here in the middle where we had that blue section. We're going to unite that. Little u stands for a union. We could spend a whole week learning about that, which we don't want to do. And then we have the second highlighted region on our x-axis. It starts at 3 and it goes on forever and ever and ever towards positive infinity. You could write the positive sign there, but it's just customary to leave it off. Looks really terrible. Keep in mind, this first part, the majority of the work is done with what we just did. So you can still get a lot of the points by doing what you already know, even if you forget this come final time.
like the time that you know, write something like this on the board or like.
I can't. I have 5 pages of instructions about how I have to administer the exam. I'm serious, it's no joke. All right, let's do another one. So now we have 0 that's greater than x squared minus 6x plus 8. We're going to start off the same way you would any quadratic. What would we do?
We would write down one and do write down
I don't know, your A, B, and C. So we're going to start off. Remember, when you start these problems, you just kind of ignore this right here, or you can consider it an equal sign. We're going to factor this just like normal. So we're going to use our asterisk and factor the original. So A is 1, B is -6, and C is 1 times 8, which is 8. So now we're on a mission to find 2 numbers that multiply to give us 8, but add to give us -6. -2 and -4, perfect. Can you reduce either side of your fractions? No, so we're gonna have factors x minus 2, x minus 4. What are we gonna do with them? Set them both equal to 0. We gotta figure out the x values. If I do that, you should end up with x values +2 and +4. Are we okay so far? So keep in mind, I don't know if I told you yet or not, part of your Ivy Tech final is going to be open-ended, part of it's going to be multiple choice. This is one of those open-ended questions where I can give you partial credit. If you get to here, you're still going to earn points, even if you get stuck on the next part. So do as much as you can on your final. You can do this. We just factored, set it equal to 0. You all know how to factor. I've graded all your Unit 1 quizzes. So now is where things change, and we have to think about those two values on our parabola. So I could go ahead and draw my parabola in here, blah, blah, blah. It would go like this, but really it only matters the 2 and the 4. We need to figure out whether the outside two regions work or the middle region works. How do we do that? Plug in. Do not plug in the 2 or the 4. You've got to plug in a number that's over here, a number that's here, or a number that's here. Did you plug in a 2? You had the guiltiest look on your face. All right, what do you want to plug in? 3? So Courtney's saying she wants to check this middle region right here. That's fine. She's going to check 3. How do we check 3? Plug it in for the x's. So we're going all the way back to the original equation or inequality. We're going to see if 0 is greater than 3 squared minus 6 times 3 plus 8. So we just took the x's out of the original and we replaced them with 3 because Courtney said she wanted to check the middle region, which is a good choice, Courtney. What'd you get? Anybody type this in their calculator and not get -1? Anybody not have a calculator and need one? Is 0 greater than -1? Yes, this is true. So in this situation, the middle region, this part between 4 and 2, is going to be your solution. So this one's going to be different because on the last part, we had 2 parts of our answers, the outside pieces. Here, we just need the middle piece. This is kind of easier to write. So when we look, I need the boundaries. What are the boundaries of this middle region? 2 and 4. So I'm going to have 2, 4, and then I have to decide whether they get parentheses or brackets. How do you know it's parentheses? So look back at your original symbol. Here's my original symbol. If I could draw, but I can't. Here's my original symbol. There's no equal to underneath it, so it's got to be parentheses. So I think this one's easier because just the middle region works. Put the boundary points and then decide parentheses or brackets. So on this one, that's our answer, right? This is your final answer. Yes. What? This? When to plug it back in or what to plug back? How to plug it back in. So always put whatever number you're plugging in parentheses. So I put the 3's in parentheses, and then you're just taking the x out and replacing it with that 3. So I took this x out and I replaced it with a 3 in parentheses. The square gets brought down, the -6 gets brought down. Boom, boom. And then I took the x out that was here with the 6 put in parentheses with a 3. And then I brought down the plus 8. And then again, we're leaving this part out. We're typing this whole section here in our count. So we're only taking the x's out and replacing them with whatever number we want. And in this case, Courtney said 3, so we plugged in 3. Questions on this one? Okay. Whoops. Looking at the one at the bottom, you tell me what to do. You draw your thing and you do your watching. Perfect. Okay, we're on the right track. So Shanika said label A, B, and C. In this case, A is 1, B is -4, and C is 3. And then we're going to factor using our asterisk. A is 1, so 1 goes in the top left, top right. B is -4, so -4 goes in the bottom middle. And then in the top middle, we want A times C, 1 times 3, which is 3. I'm fine with this. Now we're looking for two numbers that multiply to give us 3 and add to give us -4. Perfect. -1 and -3. Add your x's to the top. Can you reduce? No, so we're going to have x minus 1 as a factor, x minus 3 as a factor. Then you're going to set them both equal to 0. All right, when you set both those equal to 0, you get x values of +1 and +3. Draw yourself a little number line. We have kind of 3 choices. We can check, oh, I should keep my colors consistent. The middle, I'm gonna label it blue, or the outsides. Which region do you want to check? The middle or the outsides? You want to check 2? So Courtney said 2, she's gonna check the middle region. So
Does the equation different if you do?
we're about to find out.
Okay. I'm just wondering,
So we have 2 answer options. You just happen to pick the one that is worked on the last one. This one's may or may not work. So we have 2 options. We're either going to get that this, when we plug in 2, is a true statement like we just did on the last one, or it's going to end up being false, and then we're going to have to check a different number. So if we go with Courtney again and we plug in 2, we're going back to the original inequality. We're taking out both x's and we're replacing them with 2. If I do that, I have 0 is greater than or equal to, in parentheses 2, squared minus 4 times, what? It works. Answer's -1. Is, really? No. 0 is greater than or equal to. Oh, I do like that. Would you pick something that doesn't work? I looked at the wrong one on my notes.
Well, I won't answer anymore.
You're out. I'm just kidding. So if we plug in 2, we happen to again get a true statement. Huh? Yeah. Okay. Andrea? Perfect. I know, James has been fixing it for me. You're all right. Yeah, she emailed me yesterday. I haven't looked at it yet. Perfect. Okay. Perfect. I'll get with her this week. Yep. All right. So we end up with 0 is greater than or equal to -1. Again, happens to be a true statement. Thanks, Courtney. So we can write our final answer because this is a true statement. I know the middle region here in blue has to work. So what are my boundaries for this middle region? 1 and 3. Notice I'm always writing in the numerical order. Don't write 3, then 1. And then decide, should I put parentheses around this or brackets? Brackets. Why is it brackets? Because up here, we had the equal to symbol. If Courtney wasn't such a good guesser, sorry, Courtney, that's not picking on you today. I personally probably would have picked 0 because 0 is always pretty easy. 0 would have been in this region right here. So we're going to go off on a little tangent. We're going to plug in 0. Greater than or equal to 0. Squared minus 4 times 0 plus 3. If I would have simplified this, so I'm testing this region here on the left. If I type 0 squared minus 4 times 0 plus 3 in my calculator, I would get that 0 is greater than or equal to 3. Is that a true or a false statement? That's a false statement, which would have told me that this region here on the left doesn't work. So Courtney's just a good guesser and saved us a little bit of work. Would I want to go ahead and plug in a number between 1 and 3 to confirm that this middle region worked? Absolutely. I want to be 100% confident on my answer. So Courtney just happened to pick 2 good numbers on the last 2 problems. But that's what would happen if you picked a number in a region that didn't work. So if we would have plugged in 0, we got a false statement. 0 is not greater than or equal to 3. So we knew. Yes, you know that that region isn't part of your answer. Good job guessing though, consistently. Questions on this one? Again, on your final, I 100% expect everybody to get this portion done. I don't want to see anybody leaving it blank. If you get stuck on this part, again, the more you do and the more you show me, the more credit I can give you. Granted, I have to follow this rubric and blah, 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 but whatever. All right. Your final is the last Tuesday of the term. I can look up the date for you. All of it. All right, let's see. How far can you get on this problem without my assistance? So see how far you can get. I'm gonna pause and let you work for a minute. All right, so for this one, we should start off by factoring the quadratic that we have. So A is 1, B is 4, and C is 3. So that gives us an asterisk that looks like this: 1 in the top left, top right, 4 in the bottom middle, 3 in the top middle. Find 2 numbers that multiply to give us 3 and add to give us 4, +3 and +1. Looking at the 2 fractions on the sides, neither one reduces, so we have x plus 3 and x plus 1. Set them both equal to 0. That's going to give us x equals -3, x equals -1. Everybody okay to hear? So the majority of you, when I looked at your papers, actually everybody I looked at, had this correct. It's the next part where we get things messed up. So on my number line, I only care about -3 and -1 and the 2 regions that are created. So we have the outside regions, there's technically 2 of them, and then we have this inside region. We get to choose whether we plug in numbers from the middle region or one of the outside regions. It doesn't matter. We're just going to find a true or a false statement. So give me a number you want to plug in. 0. What region does 0 fall in? I heard left, right, and I heard middle.
So, because I wrote my numbers.
You gotta write them in numerical order. So it has to be on the right because 0 would be the next number. If I was filling in my number line, this would be -2, -4. You get the gist. You don't have to fill in all those regions, but you've got to know your numbers to know that 0 has to be in this right region. So if we plug in 0, that's fine. We're going to go back up here to the original. 0 less than or equal to 0 squared plus 4 times 0 plus 3. This portion right here is what I would either figure out in my head or use my calculator for. If I do that, 0 squared 0, that term doesn't matter. 4 times 0 again is 0, doesn't matter. So I just end up with 0 is less than or equal to positive 3. Is that a true or a false statement? True. So this is true, which means this region must work and this region must work. That also means if you would have plugged in -2, where we put our 2 zeros here in parentheses, you would have gotten a false statement. Did you do that? If you get a false statement, just check a number in one of the other regions. Okay, this is the tricky part, and off camera, this may or may not look like the one that's on your final. Sorry, that seizure.
I have a question.
Yes,
So, I think -4.
perfect.
So.
So you found out another true statement that told you this region worked. If the left region works, the right region's gonna work.
Because I have the same answer.
That's fine. Because remember, it's a parabola. It's gonna be symmetric on both sides.
So the answer can be different, it'll still be the same.
As long as it's a true statement. If we would have plugged in +1, we would have got another true statement, and it still tells us that the right region works. So it doesn't matter what number you plug in, you just have to know what region it came out of. If you get a true statement, regardless of what the true statement is, if it's true, that region pulled the number out of works. So this is the tricky one where you have the two parts of our answers. Agree, this number line continues on forever and ever and ever and ever and ever and ever and ever. Where's it go? Close, negative infinity. Can't ever get there, so it has to be a parenthesis. It stops at what? Hold up. Where's my breaking point? Where's my stop and my start? Has to be one of these two numbers we found over here.
I think I did one first.
Can't, that's not in numerical order.
Okay,
So you have to write your numbers in numerical order. -3 is smaller.
Negative infinity and then -3, and then my bracket. And then-
Bracket, perfect.
And then the bracket.
Yep.
And then my -1, and then my
Yep.
positive infinity.
Yep.
Okay. Well, then I just want my numbers to work.
Yes.
Oh, see, listen, when it gets into the negative, I get confused on how to write them. I'm like, does it go this way? Does it go this way?
So when you deal with negative numbers, the bigger technically the number is, the smaller it is. So if you had a negative $100 in your bank account, you've got more money than if you have negative $300 in your bank account. So negative 300 is smaller because you have a lot less money. You're in a lot more debt. All right, so this left region right here in yellow is negative infinity all the way up to -3. We used a bracket because of this symbol right here in the original. Because it's got that little line underneath it, we're using a bracket. Then we're going to unite that region.
So you don't have this part right there at the bottom where you just let it, you don't have that in order, so it'll still be wrong.
I have to take off of the 5 point, which isn't bad, it's an 80. But we're gonna achieve as many points as we can. We want as many points as we can. All right, talk to me about the right region. Where does it start?
-1.
-1, we're using a bracket, why? Because it has the equal to underneath it. She's fine. Does this region ever stop? No, it goes on and 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 on, all the way to positive infinity. Positive and negative infinities always get parentheses because you can never get there.
There's always one positive and always one negative.
Yes. And your negative infinity will always be on the left.
Got it.
So really, when it comes to writing these type of answers, the only things you're going to change are going to be this right here and this right here. So you can change the number and the bracket to a parenthesis, the number and the bracket to a parenthesis. Those are the only 4 things you're allowed to change. Everything else in your answer has to be the same. It's going to be a parenthesis, negative infinity, comma, something. Can you? Absolutely. Bracket or parenthesis, bracket or parenthesis. I don't really know how to write this. Makes sense, but something, comma. So these things were, oh, I just marked. These are allowed to change.
numbers will always have a bracket.
or parentheses. So it depends on the original symbol up here. So these have brackets because the equal to underneath
Yeah,
it.
that's what I'm, that's what I meant, like, if you have one like that, like, with the infinity, the bracket will always be around the number. If you ever have it around-
You can never have a bracket around positive or negative
That's
infinity.
what I'm
Yes.
saying. Okay,
So you can't ever have a bracket around positive or negative infinity because you can't ever get there. You can't ever touch it.
Okay.
So you can't ever include positive infinity because I can give you a number bigger.
Oh.
Regardless of how big your number is. All right, take a break. Take a break.